Well, another Monday is here. I figured I'd hit you guys with a little bit of a tutorial on some air conditioner stuff and a little bit of history and a little bit of change that's been going on. And there's a lot of stuff. You could go on and on and on covering all of this stuff. And I'm not going to talk about R1234 right now. We're just going to cover the systems that are mostly out there. And back in the day, the old cars, years, I mean, used to have these suction throttling valves. And the compressor ran all the time when the control head was set to AC or defrost, and dehumidifies the air, and defrost, keeps clears your windshield up quicker. In some luxury models, the compressors simply just ran all the time. They never turned them off. They just let them run whenever. But this suction throttling valve was interesting because, here was one that we worked on this Cadillac, and excuse me, from the evaporator, you got this thing coming in to this valve going out to the compressor. Got an oil bleed line from the bottom of the evaporator. Charging port was on this thing, and a pressure equalization port to the expansion valve. So it worked in conjunction with the expansion valve, and this thing could give trouble, and you would be thinking that, what am I going to do? And a lot of the times whenever you would go ahead and just replace this thing, it would take care of a problem that was beating you up, But anyway, these things are pretty much gone now, but that's a little bit of history there. But it was basically all about preventing the evaporator from icing up. We talked about this last week. And it works in conjunction with the expansion valve to drop high pressure warm liquid refrigerant to a low pressure cold liquid, but keep it from getting so cold the evaporator would freeze. Whenever the refrigerant basically boils at 21 degrees below zero or something like that. I mean, it varies from refrigerant to refrigerant, but the point is, as it turns from liquid to vapor, it absorbs heat. Water does too. When you get out of the shower, that's why you feel cold sometimes, or when you get out of the pool. Preventing the evaporator from turning into a block of ice is kind of important. Now, expansion valve systems change the size of the liquid line orifice based on the temperature of the suction line as it leaves the evaporator. This was the one I mentioned last week where we had put an expansion valve on this Toyota Camry because it was giving us low readings on both sides even though it had a full charge, and then we wound up putting an evaporator core on it to take care of that problem. But this sensing tube here, see that sensing tube, basically is reading the temperature of the refrigerant, and then it's causing this valve to open and close. That's why they call this a thermal expansion valve, right? Because the temperature makes it open and close. And some of these things can get clogged up with some of them, like some of the Volkswagens I worked on at the dealership back in the early 80s, had a screen right in here, and whenever that screen would stop up, it would keep any refrigerant at all from being able to get into the evaporator, and the air conditioner just wouldn't work. And we'd have to get in there to try to, clean that screen out or replace the expansion valve or whatever. Well, newer expansion valves are made like a block, like this one here, and they're hooked up this way so that both the liquid side and the liquid and the suction line both go through the same thing. So it's internally reading the temperature rather than having that tube that you saw on the other one. You notice this looks a lot like what that same kind of diaphragm driver that you saw on the other kind of expansion valve. Alright. The orifice tube is in the liquid line. It can be anywhere in the liquid line. On some of them, you got to replace the entire liquid line to replace the orifice. On some of those older Chevys that had it behind the grill, right there coming out of the condenser, it was so annoying because you'd go to take one of those loose and they was fitting with gall, and it would just be a real big problem because you'd have to wind up replacing a lot of stuff that the customer didn't want to replace, or didn't want to have to replace. But if you're going to replace this orifice, you got to take those lines apart, and then when they're galled and they take the threads with them, this variable orifice valve here is sort of a modification that people would use sometimes, and that's a pretty interesting piece of hardware. You don't see these very much, but you can get them, and they're made so you can replace your regular orifice valve with them, and it's a variable orifice valve. I don't know if you've ever heard of those or not. This was on a Jeep Grand Cherokee where I wanted to look at the orifice because I knew it was in this liquid line. And I just cut the liquid line so I could get a look at the orifice. You could not replace this orifice on this one without replacing the liquid line. What I was talking about, and I used this tubing cutter to get in there and have a look at it. And sure enough, it was all full of crud and caving in and everything else. You don't often think about replacing the liquid line, but you need to if the orifice is built into it. Alright, you got low pressure cutout switches. We've talked about those some. They cycle the compressor off when the low pressure drops below a certain threshold, usually about 25 psi. These kind usually actually had a screw in them down in between the terminals where you could adjust them a little bit. When I was working at the Lincoln dealership in '84, there was a town car that came in there, and it was machine gunning the compressor going da-da-da-da-da-da. It was the craziest thing I ever seen. And just experimentally, I unplugged the wires from this thing because it had a switch like this on it. And down there at the bottom, I turned that screw about a quarter of a turn, and that completely stopped all of that. That's the only time I ever saw that. You know, I can't think of all the times that I saw something one time and never saw it again, you know, but I always filed it away in my memory. High pressure cutout switch. A lot of times, ever since like the early 90s when things went 134, high pressure cutout switches became a thing on most every car. Back in the older ones though, they would put this switch in here. You can run this with or without it, but if your old system had one, and these are color coded too, by the way, so if your old compressor had one in it, sometimes you can't get the thing out of there. You know, it's really annoying. Pull that clip, pull the plug, there's an O-ring here, and this, you know, you slide that down in there and then put the snap ring back on it. But you notice how on these, when the heater, you got voltage coming from the heater control, and the AC high pressure switch, and I've talked about this one on the Jeep, whenever the pressure goes high on this one, see on the one that is set up like this, you know, they're not all equipped with this, but you can see this is alternate current path right here on some vehicles, but that's a 2.5, it's a 4 liter. And so here you got this switch that turns on it requests the radiator fan, and it also kills the AC. See if the pressure goes too high, and so it's taking measures to make sure the pressure doesn't go too high. The low pressure switch and the high pressure switch are wired in series on this one too, although it doesn't have the fan request part of it because it doesn't, I mean, it's got a totally belt driven fan on that particular one. But just remember, these are usually wired in series, so that if either one of them opens up, it kills the compressor. That's just, you know, that's an easy thing to remember usually. And vehicles downsized, engines got smaller. The feel of the AC compressor switching on and off was annoying, like it was on my Rabbit that I was talking about a while back. And so they basically come up with different ways of handling this. Scroll compressors were one way they did it, because scroll compressors don't put quite as much of a load on the engine as the old piston swash plate type. Compressors got smaller, they got lighter. There's your scroll type. Got them, you know, flutter valves back there. This one here is one I'm going to talk about a little bit more in a minute. Variable displacement. And this one right here is a standard compressor with a swash plate. When this one spins, these pistons go back and forth. This one's spinning too, although it's really odd to me that they put a compressor clutch coil in this one, because these kind don't have a compressor clutch coil. I mean, this was a display at Randshoe when I went to the Max convention one year. They had these compressors on display, and I took pictures of them with my camera. But anyway, that's this plate right here. Well, the angle of this plate can change, and that changes the displacement of this piston, so that as this thing's spinning, if this plate is vertical, the pistons aren't even moving and they're not compressing. But as it changes the angle of the plate, you know, rather than cycling compressor on and off, it changes the angle of the plate to determine what to do with, you know, I mean, how much compressor operation you need. Now, this variable displacement was born to keep passengers cool while reducing load on the engine. There's no clutch necessary, but the pulley's designed to break away and freewheel in case something locks up, and sometimes that happens. If the, you know, if the pressure on a really hot day, sometimes it'll happen if that thing's got, if the little dogs in there are weak on that compressor clutch. See, this one right here, you notice you don't see a compressor clutch coil in this. It's just got a pulley riding on a bearing, And the clutch is always, this is actually, see the screws part of this? This is an illustration I borrowed from Valio, one of their compressors. And this is a variable compressor right here. There's a bunch of different ways. There's these actuator, you know, that sometimes it uses refrigerant pressure. You know, there's various different ways it works. But anyway, that's now the wobble plates versus swash plates. Axial style compressor has been around since the early 60s. Like this thing here, this thing is huge. It weighs 30 pounds. You know, you have to hold that thing with one hand while you're putting the stuff. You'll know something there. But this one had a fixed angle swash plate. The old compressor was really heavy. This newer one, I've demonstrated this new one.
When we spin that thing, pistons going both ways. Alright, so now that we got pistons going both ways, on each end of this thing, we've got these plates here, and they've got little flutter valves in them. And those flutter valves let it pull in, and then they push it back out. And so that's basically the operation of the air conditioner compressor.
Sorry, I didn't mean to talk over that video. I forgot it was going to have sound. But anyway. Alright, now the variable displacement compressors, the heart of them is the variable angle wobble plate, like we were talking about earlier. Some of them are internally controlled, some are externally controlled, some are electronic, some are pressure controlled using refrigerant pressure. When the wobble plate's nearly 90 degrees in relationship to the input shaft, it has very little wobble as the compressor spins, and therefore the pistons only make a very slight movement back and forth in their stroke. You can see it working down here in this animation that I've created. The desired angle of the plate is controlled by the valve in the side or the back of the compressor, which is a pretty handy way of handling that, really. If a variable displacement compressor's wobble plate gets stuck more vertical, cooling will be poor. If it gets stuck in a high displacement position, it's going to freeze the evaporator. If the compressor locks up, it will shear these breakaway connections here, and the pulley will just spin freely rather than slipping the belt. Alright, because low charges and overcharges can emulate other problems on one of these systems. You do a recovery and a recharge with the correct amount of refrigerant, get a good baseline. Now I'm going to say this, if one has been recovered and recharged enough times, like this one lady had a Taurus at the Ford place, had pulled the refrigerant out and recharged it so many times that they had removed a lot of the oil, because every time you recover it with a machine you take some oil out. They didn't factor that in, and after 4 or 5 times of recovering and recharging, they had removed enough oil from her system that it locked up her compressor. But anyway, the other thing that you need to consider is you need to, and on my Jeep I ran into this. My Jeep 2001 Cherokee held 1.25 pounds of refrigerant, and I had pulled it out and recharged it a few times, demonstrating for the students or whatever. And one day I decided I was going to just pull the juice out, and you pull it out, see how much is in there, see if it was low, and then put some back in. And I was working in my office, nobody was there but me. I turned on the machine and it pulled refrigerant out. And so I went back in the office and worked, and I said, oh, I got my Jeep out there. So I went out there and looked, and the refrigerant pressure had gone back up. I had pulled about 1.2 pounds out of it, but the refrigerant pressure had outgassed, meaning the refrigerant had come out of the oil that was in the accumulator like a fizz coming out of a carbonated drink. And so I went ahead and recovered that pressure that had come out of it. Anyway, by the time I got through going through that recovery and let it outgas some more recovery, there was 2 pounds of refrigerant in my Jeep, and it was only supposed to hold 1.25. And so that's why these newer J2788 compressors, refrigerant machines are supposed to pull more of the refrigerant out faster than the older machines, but you could recycle the older ones a few times and make sure you got it all that way. It just took a while. It also helps to warm the engine up and heat the engine compartment up really, really, really hot before you ever start pulling the refrigerant out. And that's going to be something you'll need to do on a cold day, because if it's 40 degrees in the shop, you bring a car in there and it's cold like that, it is hard to get all that refrigerant out of a system that's cold like that. And I'm not talking, never vent it to the air. If you don't have the equipment to remove the refrigerant, you know, find a shop you can work with where you can go say, hey, I need my refrigerant pulled out because I got to pull these lines off to replace a valve cover gasket or whatever. Don't vent the refrigerant to the atmosphere, and don't ever work around a refrigerant system without eye protection either. But after you receive the recovery recharge, you don't see any spots freezing to indicate a restriction. It appears the compressor is not pumping any or throttling back. You likely have a compressor displacement control problem. See, this is something you can't watch with your naked eye. If it's electronic, you'd check that out prior to going after the compressor. You know, the wires and all that. With the variable displacement control valve mechanical, you can put a new control valve in it, unless it's really aggravating to get to, or you can go with a newer remanufactured compressor. If the compressor is noisy, or the inlet screen orifice, tube screen, if you pull this orifice out, you can tell a lot about what's going on in the system because it's like a screen that will trap stuff. You replace the compressor if you got a lot of nasty metal and debris in there anyway. The pieces of Teflon from the seals on the pistons. You might consider replacing the control valve if you can do it without removing the compressor though. If they decide to go that route, it's smart to say, hey, this may not fix it, but we're going to try it, and then give the valve a try. So, now, if you drive it, electronic control of the variable displacement side of the compressor is really more common. GM has adopted a CVC solenoid. Toyota has done the same thing, and you know, continuous variable control, I guess is what that stands for. I may be wrong about that. Correct me if I'm wrong. Scan tools PIDs for the newer GM compressors display the duty cycle percentage for the solenoid controlling the compressor displacement. They may have them where they'll, if it's actually calling for a different pressure, because it's a feedback thing, I'll show you that in a minute. If it's calling for a pressure it can't reach, you may get a performance code for that, this kind of thing. But if you can't read the PID on a scanner, you can grab a digital multimeter with the duty cycle function. This is the meter that I own, and watch the percentage increase as you dial down the temperature on the control head. So if you get on that thing, you're measuring hertz. You know, hertz is cycles per second. I hooked this up to a wall outlet, and you can see about 60 cycles a second on that. And then you can actually watch that thing and read. And what I like to do in a situation like this is get used to what they're supposed to look like when they're working right. And that way you can compare that in your mind to what you're actually seeing on a problem car. And so just like any other thing, if using a scope, a scan tool, or anything else, or even a voltmeter to measure voltages and sensors, if you know what they look like on a good car, you can find the problem easier on a bad car. Same way with this. Alright, the PID for the compressor displacement solenoid is displayed on the data stream as current, corresponds to the duty average cycle time of the solenoid. A diagnostic trouble code sets if the pressure is not matching the solenoid's commanded state. That's what I was talking about. I don't know if they all do that or not. That's why I was giving you that disclaimer. Standard input-output feedback loop, though computers have used these feedback loops forever. Electronic compressors are the standard for most hybrids. 05 to 09 Ford Escape Mercury Mariner had mechanical compressors. Some Hondas used a compressor that was 2/3 mechanical belt driven, with the remaining rear third of a compressor being orange cable high voltage feed. You know, the orange cables on the hybrids, the ones that's the high voltage ones. For electric AC compressors, use the kind of oil you're supposed to use so it doesn't melt the insulation off of the wires in the motor and destroy the compressor and feed back high voltage into the ground circuit on the car. That would be bad. Electric compressors, you know, have to have hundreds of volts to work. You can spin an electric water pump at 12 volts, but an electric compressor is going to take a lot of voltage and a lot of current. The higher the voltage, the less current you need. See, and these compressors can run with the internal combustion engine off. And if you hear a slight growling noise from the high-speed motorized compressors, that's normal. That's what that looks like in there. And then you got this scroll on the other end, and you can see you got a brushless motor. These things are always brushless motors. I mean, a lot of the motors are getting away from brushes. Even in fuel pumps, they're starting to use brushless motors in fuel pumps on gas burning cars. And they even have they have to have a module to operate that brushless pump. And so you see that. I know particularly on GM cars they're using those, and I'm sure they're on other vehicles too. Alright, 3 and 4 pounds of R12 in vehicles years ago was normal. Now, they'll usually be less than a pound. And that's a really good thing, especially since your 1234 is, you know, 40 to 60 bucks a pound if you're buying it at the parts store. It's going to be winding this little short video up. I just giving you a few principles here. I hope you have a great week. And hey, let's be careful out there.